Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students in data management who are studying for the Unit 1 test on counting principles. In this video, I'll take up some permutation and combinations questions from the review material. So here's the question that we're focusing on for this video, and I encourage you to press pause and try this question on your own before watching the solutions that are coming up. Okay. So let's examine what this question is asking. It says a permutation of 6 letters is formed from the letters A, B, C, D, E, F, G, and H. So we're starting with this set of 8 letters, all of which are unique, and we want to create a 6-letter permutation. And remember that permutation is also an arrangement. So obviously order matters, so we can use factorial, we can use fundamental counting principle, or of course permutations itself. So one example is here. So here is a 6-letter permutation made up of only elements in this 8-letter set, and again it's 6 letters long. So that's one of all possible permutations. So before we look at part A, let's just consider how many permutations would there actually be if we ignore any restrictions or rules that are coming up. So if I have 8 to begin with and I want to fill 6 positions, so using the fundamental counting principle, first of all, I would say that to fill this position, I have 8 choices. So I could choose any of these 8 things. So that gives me 8 choices for the first position. Once I choose an object, or one of these letters to fill that position, so let's pretend it was B, I now have 7 choices as to which letter to put here. And so let's pretend it was this one, and now I have 6 choices, and continuing on I would then have 5 choices, 4 choices, and then 3 choices. And using the very concept of fundamental counting principle, I need to make all 6 choices to finish one permutation, and that means that each of these choices would be multiplied by each other to indicate the total number of decisions I have to make when I am arranging these 8 unique objects into 6 positions. Of course, I could just multiply that together, but we have learned that there is a shortcut called permutations. And if I have, in this case, 8 unique objects to fill 6 positions, I can do 8 objects to fill 6 positions. And that would simplify things certainly just by finding that button on your calculator. And we often say 8p6 or 8 place 6. And again, that means 8 objects that are unique to fill 6 different positions. And so there's 20,160 total of them, one of which I've written here. So let's look at the actual questions. So here's what part A says. So of the 20,160 possible, how many of those begin with the letter A? So the first position, the first letter of the 6 has to be the letter A. So I'm going to place it there. And then the A is no longer a choice I have, and I no longer can choose anything for that first position. So I don't do any math with that A, and I don't do any math with the first position. Instead, all my math is now these 7 unique letters have to fill these 5 positions. So this question is really saying if you have 7 unique objects to position into 5 different positions, how many ways could you do it? So 7 unique objects to fill 5 positions. So 7p5 would be 2,520. Now we want all the ones that do not begin with A. So there's 2 ways to approach this, one of which is to just say, well, in this question we found that there were 2,520 that begin with an A, and so all the other ones must not begin with an A. So if we go back where we said that, we said that there were this many, 20,160 total. So the total number of rearrangements is 20,160. And we discovered that there are 2,520 that begin with A. Then the difference, all the other arrangements must not begin with an A. So there would be 17,640 that do not begin with A. That's one way you could get the answer, because there's the answer. But let's also look at the other way to do it, which is, okay, if this can't be an A, I have 7 choices as to what goes next. So I will make that decision, which is to say I have 7 choices. When I go to the next digit, or the next position, I've chosen one of those 7. So let's pretend it was this one. Now I'm allowed to choose A again. So now I have 1, 2, 3, 4, 5, 6, 7 more choices to make. Then once I start filling in the rest, now I just say, okay, now there's 6 more letters available, 5 more letters, 4 more letters, and 3 more letters. So you could say that it's 7 times P7, comma 5, or just do that multiplication, and you should get the same answer, which is 17,640. So because we'd already done part A, this one, the complement method, was pretty fast, but this method is not that much more work. Okay, next question. So how many of the permutations end with a vowel? So let's consider this position because it has to be a vowel. The only vowels available are A and E. So there are 2 choices to make regarding what this arrangement will end with. Once I've made that decision, the rest of these positions, so these 5 positions, can be any of the letters that remain, including the other vowel. So once I've put a vowel here, let's pretend it was the E, I'm going to have 7 letters left over. And of course, if it was the A I'd put there, I still have 7 letters left over. So once I make that choice between A or E, no matter what, I'm going to have 5 positions to fill and 7 letters available to fill them. So these positions will be filled this many ways. So the math I'll do looks like this. Multiplied by 2 because of the 2 choices I make. So 7P5 and then times 2 is 5,040. Of course, if I were to write this, I would probably have written this, just because I like to indicate sort of, I did this choice first, and then I made all these choices. Either way, it's the same math, obviously. Now we have to make a permutation of 6 letters, but that only contains the consonants. So the A and the E are not allowed to be used. So I'm actually going to just really get rid of them here. And that means that there are 6 letters that I'm allowed to use, and of course there's only 6 positions. So really, this is a question where I'm placing 6 objects into 6 positions, which is also just 6 factorial, which is 720 different ways to do that. So now I need to create a permutation of 6 letters that contains an H, but not a G. So I must have an H, and I'm not allowed the G. So first I'm just going to cross out the G. I know I'm not allowed it. Now I must have the H. So I'm going to sort of demonstrate 2 different ways you could approach this. First of all, the way that involves permutations only, which is I'm going to force the H to be right here. Now, keep in mind, there's no reason why the H has to be at the beginning, so I'm going to adjust for that later, but I'm going to force the H to be here and only worry about what these 5 positions might be. So if I force the H to be here, I've taken it off of my choice list, and I now have these 6 letters to fill these 5 positions, which would be 6 letters into 5 positions. But of course, there's no reason why the H had to be first. The H could have been here, or here, or here, or any of the 6 positions. And no matter which of those positions the H was in, so let me just kind of recreate this. Let's say the H was here. No matter what, I would still have 5 positions available and 6 letters to fill them. So really what I'm doing is I am doing 6 positions to fill 6 letters to fill 5 positions, and I need to do that for all 6 of the different places where that H could have been placed. So when I multiply by 6, I'm doing this math 6 times to represent where the H could have gone in the word. So that is 6P5 times 6, 4,320. Now I said there's another way you could have approached this question, so let me demonstrate that. And keep in mind that this approach involves choosing. So if you've only studied permutations so far, you know, this approach isn't going to work for you. But of course, the test is on both, so you could use both. So here's what I'm going to do. So obviously, I'm going to cross off that G again. I know I can't have it. I must have the H, and I need 5 more letters. So what I'm going to do, first of all, is I'm going to choose which of these 5 letters to use in addition to the H. So I've chosen the H, and I've also got 6 letters, and I need 5 of them. So I'm going to choose my 5 letters. Once I've chosen my 5 letters, I basically have 6 letters to work with. So I have the H, and I say, let's say I chose these 5 other letters. Now I have selected 6 letters, but I haven't put them anywhere. All I've done is chosen which letters to use. So now I'm just going to take the 6 letters I've selected and arrange them, which would be 6 factorial. So when you do this math, you get the same answer, which is 4,320. So both of those are perfectly acceptable methods because, of course, the test involves factorials and permutations and combinatorics and combining. So whichever one makes more sense to you, that's a good approach. Now we need A and B to be in adjacent positions. So my approach to this is to take A and B and glue them together and think of them as one letter. And that means that I have to consider having one less space available to fill because the A and B takes up space, obviously. So let's pretend that the AB go here. So there's that letter called AB. And then that means that I have 6 letters left to fill 4 positions. So that would involve a permutation of 6 objects into 4 positions. But of course, that AB didn't have to be at the beginning of the letter. So it didn't have to be in sort of the 1-2 positions. So now I'm going to think, okay, well, how many different ways could I have placed the AB? So I could have put AB here and here. That's one way. Or I could put AB here and here. That's another way. Or I could put AB here and here. Or here and here. Or here and here. So there are how many different places could I put the AB? And I realized that got super messy super fast. So let's do it again and keep track. I could put AB here and here, so I'll mark 1 and then I'll erase. Or I could put AB here and here, so there's a second one. And hopefully you are like, just, we get it, miss. Yeah, okay, I can count, but you know, you never know. And so there's another one here, and then mark that one. Whew. Easier with pen and pencil sometimes. And then finally this one. So there are a total of 5 ways that 5 positions I could have placed the AB double letter into. And what that means is no matter where I place AB, so let's say I put them here, I still have 6 letters left to fill 4 positions. So that means that I have to take the 6 letters into 4 positions and multiply by 5 to represent the 5 different locations that the AB letter could have been. But we're not done yet, because every time I put AB somewhere, I could have put BA and still satisfied the adjacent position criteria. So AB could have been BA, which means I'm going to multiply by 2 factorial, because what I'm doing is I'm taking these 2 objects, which are locked together, and saying these 2 objects can be rearranged in this many ways. And so if I do this math, 6p4 times 5 times 2 factorial, and I get an answer of 3,600. And that's where A and B are adjacent or side by side. A and B separated by exactly 1 letter. Okay, so let's think about what that would be. So I'm going to start by putting A here and B here and saying, okay, well, there's that big now triple word, and A and B. So I've got A and B. and there's 6 letters left. So what letter goes between them? Well, I have 6 choices as to what goes between them. So that's the first thing, is to think about how many different ways could I form this A something B triple word. Once I've made that decision, I've used up one of these letters, so I'm down to 5 to fill these 3 other spaces. So these 3 other spaces will be filled using a permutation of the 5 remaining letters into 3 positions. So far I've made a choice between 6 things, and then I've done P53 to fill these. So 6 times P53. But now I have to consider that this big word, A something B, didn't have to be in the first 3 positions. It could have been anywhere. So now I need to figure out how many different locations could I have put A something B. So this big triple word. So let me do this. So I could have put A triple B. So it's 3, it takes 3 spaces. So it could be these 3 spaces, or these 3 spaces, or these 3 spaces, or these 3 spaces. So there's 1, 2, 3, 4 different locations that I could have put A blank B. But I'm not done, because the final thing we have to consider, just like in the last one, is that if I have A blank B, I could have also had B blank A, and I need to consider that. So I'm going to multiply by 2, or by 2 factorial if you want, to consider that all of the math that I did for A blank B would be repeated for B blank A. So there's lots of steps to this one. Hopefully they make sense. So when I multiply all of this stuff together, what do I get? 2,880. It's a good question, because there's lots of little things to consider. All right, next. We need to start with the word bad. So that's kind of nice, because there's no choice involved here. It must start with these exact letters in this exact order. So there's a lot of things I don't have to worry about. The letters B, A, and D have been used. I can't use them again. And these 3 positions have been filled, and I don't have to do any rearrangement within this word BAD, because I need it to be exactly BAD. So really all I have to do is consider that I have 5 letters left, and I need to fill these 3 positions. So that's just P 5, 3, and I don't have to do anything else. Again, I can't move the word bad around. It says to start with it. I can't rearrange the word bad. So it's just P 5, 3. So 5 letters filling 3 positions, and that is 60 different possible ways. So now we get into where we mess around with that idea, which is we just want it to contain the word bad. So let's reestablish what we just had. What we just had was where we started with the word bad, and then we filled these 3 positions with the 5 letters remaining. So again, BAD were used, and so we had said these 3 positions can be filled with these 5 letters. But now we have to consider that the word BAD doesn't have to be at the beginning. It just has to be somewhere in the order BAD. So we now have to say, well, how many different locations could that 3-letter word BAD be? So it could be BAD. So I'll just put the B to represent that thinking. So BAD. Or it could be here, BAD. Or it could be here, BAD. Or it could be here, BAD. And of course it can't be here, because if I put a B here, I don't have a spot for the D. So that one's no good. So there are 4 different locations within this 6-letter permutation that I could put the word BAD. So I've multiplied by 4. Now I don't have to do any other adjustment, because the word BAD doesn't get rearranged. So I just have to do permutations of 5 letters into 3 positions, but this times 4 to represent where that BAD phrase could be. So that is 240 different possible permutations. And now I just needed to contain the letters BAD. So I don't have to have B followed by A followed by D. I just have to make sure that of the 6 things, that somewhere I use the letters BAD for sure. So there's two ways to approach this. So let's start with, I guess, the direct approach, which I'm going to do using choosing, which is to say I know for sure that I need the letters B-A-D, and then I need 3 more letters. So I'm going to start by selecting or choosing which 3 letters I want to include, and then I'll talk about arranging them. So there are 5 available, and I need 3 more. So I'm going to do 5, choose 3. Now I have B-A-D and 3 more letters, whatever they are. And now I have 6 letters total that I need to now place, because don't forget, I haven't actually made a choice about where anything goes. So I have 6 letters thanks to this choosing, and I just have to place them. So if I have 6 letters to place into 6 positions, that would be times 6 factorial. So if we do the math on that, 5 choose 3 times 6 factorial, we get 7,200. So the other way I was thinking about doing it was to count all the ways that do not contain the letters B-A-D. The problem is that that's pretty confusing. Let me think. Is that actually going to work? Because the problem is I'm allowed to include A and B. I'm thinking of the opposite, right? So I'm trying to think of how many ways could I make a permutation of 6 that doesn't include B and A and D? And that's actually going to be pretty complicated, because A and B would count, B and D would count, just D would count. So you know what? I'm not going to show you another method, because this method was by far the easiest, which is to include choosing and then positioning. And I think that's the end of the questions. Good. So just a reminder that if all you're doing is watching videos or looking through your notebook, you're not actually studying math. Please make sure you're trying as many questions as you can, even questions you've done before, because studying math means doing math. Okay, hope that was helpful. Good luck in your studying.